A factor that directly impacts the user experience design is the form factor. So if you have been developing different types of applications for different devices like smart TVs, tablets, laptops, and mobile phones, you probably already know that each of these we call form factors have their own characteristics. The main difference is they have different sizes of screens, but also they have different modalities of being controlled, from a remote controller versus touch screens and other means. Most of the time, web development frameworks or the mobile application development frameworks, they actually define what is a form factor means. So they usually tell the developer, okay, if you are developing an application for a TV, you need to follow these guidelines. But in pre-IoT era, these form factors are distinctly defined, especially by the industry and the people who are developing the developer tools to make your life easier. So most of the new web and mobile frameworks actually is capable of doing some amount of transformation between these different form factors autonomously without you as a developer doing anything. And these frameworks are not perfect. So most of the time you need to do some amount of work by yourself, but the form factors from the TV to the tablet to the mobile phone to the laptop is fairly strictly defined. The problem becomes in IoT, these standardizations are not existent at all. For example, you might find yourself in a situation where a particular IoT device does not have a screen at all. And then even you have a screen, it might be very varying in size from product to product. So there are no standards in IoT in terms of what a form factor would look like. Therefore, it becomes much more complicated to develop applications for IoT systems. Because of this heterogeneity, we see more and more custom developed IoT applications where both hardware and software being developed by the developers or the manufacturers themselves, and they optimize their design into a particular IoT system rather than developing applications that could run across different IoT products and systems. Let us now discuss what is the difference between Internet of Things applications or the systems and the applications we know before Internet of Things, such as mobile or web applications. So Internet of Things application development inherits all the complications which we had before. Cross-platform design, different programming environments, and all these kind of things. In addition, previously we also discussed about the challenge of having different form factors. But IoT make it a bit more difficult because now the form factors, previously we dealt with different sizes of screens, and now we have to deal with the disappearing of the screens altogether and be able to deal with different types of interfaces. Another less obvious difference is that most of the IoT systems are expected to have only limited internet connectivity, which is much more unreliable than any other platforms we worked before, such as web or mobile, where the network connectivity may not be critical as much as in an IoT application system. For example, a similar task such as internet-connected door lock becomes a complicated programming or the development task when there are multiple components need to be interact to each other in order to make the application works. Let's consider the application of a internet-connected door lock. It is very likely that the door lock doesn't have a user interface or the user screen as we know traditionally exists at all. And also most likely you will be interacting with the door lock using a mobile phone or some kind of a device that has NFC or RFID or any kind of identification tag which door knows that it need to be opened. But then it might also have a remote connection where I can open the door for someone else where I am located in my office, and then when someone come near to my door, especially if it is a family member, then I may open the door for them remotely. So then you need to have the internet connectivity directly connected to my office from the door to make that happen. And also there could be other occasions where I will need to open the door without the mobile phone in a normal putting the key and open the door kind of fashion. So as you can see, these internet connected door lock become increasingly complicated to support different use case scenarios where they need to support some use cases that we would not think about when we designing systems in a pre-IoT era. So the bottom line is that we need to think about the devices, services, users, and different types of use cases when we are designing IoT systems. Before we dig deep into Internet of Things user experience, first we need to understand clearly what user experience mean. Most of the people think that user experience and the user interface are the same, which is not. So user experience is a holistic and a broader term where we encapsulate different aspects such as being useful, usable, pleasurable experience for the users. User interface is only one of the aspects we consider when developing or designing an overall user experience. So the user experience is a broader term, and then the user interface is one component within the user experience. And also the user experience is the way that we design a solution to solve a particular problem. User interface is only one way that we could go about solving the problem, but it is not the only way that we can solve a problem. In IoT systems development, we face the challenge of distributing functionalities across different devices. In traditional web and mobile development environments, we also had to make some decision on what kind of processing that need to be happen on the cloud, what processing would happen on the phone, those kind of decisions. But most of the time the user interactions would happen between the mobile phone or the tablet and the user. But IoT has changed this significantly. where we need to make more complicated decision on when are we going to process or perform a particular action or the interaction with the user, and what device is actually responsible to carry out that action. We will be discussing these kind of challenges later in this lesson. Increasingly, IoT is become a service than a system. For example, if you look at the previous internet connected door lock scenario, in that case, we are not thinking about IoT system. We are thinking about securing our house, which this internet connected door lock is part of. Nobody cares actually how the system works. So when you are developing or designing an IoT, a door lock, your responsibility is to think about how to provide this user experience of or the service of securing their homes or houses. An important difference is that when you are developing a news application that works on a mobile phone, you most probably don't care about or worry about getting disconnected from the internet. Maybe the application might be stuck for a while, or it will give some message to the user saying that the internet is not connected or the connection is poor. But the user is pretty much understanding what is going on, and then they might probably wait until it is get connected back. But if you are looking at an internet connected door and then the door cannot be opened because of the internet is dropped or unreliable, then that is become a problem, especially if it is starting affecting the real life work. Therefore, if an IoT application or IoT system has a glitch, it becomes very noticeable, and then it could also become more annoying than you have a glitch in a mobile phone application. Therefore, you need to be very careful that to make sure that you don't have any major glitches in your applications, and also have some backup plans or the backup ways that users can interact with your IoT system if the internet connection become unreliable. You may also notice that most of the IoT systems are largely asynchronous, which means when you, for example, when you press a button to increase the temperature, it doesn't directly increase the temperature of your room. Most of the time it will push a message to the cloud or a shared smart hub, and then the actual heater time to time monitors what are the messages going on this either cloud or the smart home hub, and then it will update itself over time. So depending on the IoT system, it could be few seconds or minutes or hours before we actually before the system starts reacting to your actions. Of course, there are certain applications you need immediate milliseconds or nanoseconds reactions, but you will see increasingly that most of the IoT systems are asynchronous. We will also see that there are multiple devices involved in a single IoT system. Therefore, the code you develop might be run on different places. You need to consider how they are working together. And you will also realize that when these systems are getting connected and they are supposed to work together, at the beginning you will feel that the systems are very simple. However, when you are adding more and more components, the number of relationships started to grow pretty quickly, and then these systems are becoming more and more complicated and even become more difficult to actually debug when you are developing these complicated systems. To make this make your life more difficult as IoT developer, you will see that there are less technical standards compared to web or a mobile domain. And also at this point of time, you also have limited technical supports or the frameworks exist to help or guide your development process. There is also a notion that in IoT, the data is the core that drives the IoT service. The whole idea of IoT or the Internet of Things became popular because it gives two promises, which is to make the efficient, so create additional layer of optimization around you so that you save resources and then save money. The other promise that IoT gives is the convenience. This means that you don't have to go and manually switch on and off or increase and decrease the temperature by yourself. It will autonomously change the temperature according to your convenience, but also looking at the data, your own past data as well as the other people's data and how other similar people behave and what their preferences are. Then thermostat will actually change the temperature based on that autonomously. So it will save your time and also increase the convenience, and then also lead to the better satisfaction and while you saving the energy bill. Because of the complexities that we discussed so far, when you're designing an IoT product or experience, you will be thinking about these designs as a layered architecture. So you'll be looking at the user interactions, network communication, energy consumption, how do you provide power or the energy to the IoT system, and the data analytics, what kind of data you need to be collected and processed and where and how, and so on and so forth. These layers at the end need to work together seamlessly to provide experience. And then the people need to, or the end users need to feel that they are getting a service rather than using a product. In Internet of Things, the functionalities are typically distributed across multiple devices with different capabilities. For example, some of the IoT devices might have screens, even they are smaller. For example, you can see in the image, in the heating controller, there's a small screen. And also you may have seen such screens in washing machines, where the users can actually interact with and make some inputs using those screens. However, some of the other IoT devices like smart pill bottles, they may not have traditional screens at all. They may be depending on flashing LED lights or sounds or vibration kind of input-output mechanisms. In such situations, we will need to depend on web or smartphone applications to interact with these devices. Therefore, overall, we need to think about not just the usability of an individual user interaction or the user interface, but the interusability, where how the users might be interacting with the IoT system across different components of the IoT system. For example, a user might be interacting with the smart pill bottle at some point, and the other points they may also interact with the mobile application that is dedicated to provide certain functionalities related to the pill bottle. We can see similar patterns in internet connected water bottles, where the bottle might be have some kind of LED or the vibration based input output mechanism, but there's a dedicated mobile application actually allows the users to provide more wide range of inputs and outputs from the connected bottle. You can also see the Nest thermostat, which also has a mobile app-based interaction mechanism, but also it has a smaller screen on the thermostat itself. And it might also provide a web-based user interface to interact with the thermostat as well. Then you can also see mobile applications dedicated to control the smart home hubs. So there could be different devices connected to the smart home hub, and then the smart home hub can be configured and manipulated by using either the mobile application or using a web interface where your computer is connected to the smart home hub through an API, and then allows you to control different parameters using your web interface. When we think about Internet of Things, most of the time we tend to think about devices. However, it is important to understand that most of the time these things are even invisible for us, or they just work in background. And also they are very much connected to the larger systems, where they are connected to the servers where data processing happens, or the communication happen over the cloud. In reality, IoT devices exist to provide a particular service. For example, in smart travel domain, the London Oyster or Hong Kong Octopus, they act as a payment service. We don't see them as individual devices that is there where people tap their cards. So in reality, even though there are a lot of IoT devices and infrastructure involved in enabling this kind of smart travel system, which not only provide one ways but also multiple ways of interactions, from mobile phones to smart cards, bank cards, or other NFC enabled devices or wearables that people can use to communicate with these payment endpoints. But overall, these endpoints or the devices that are visible to the public are almost invisible, in the sense that we don't think them as a device, but we think them as interacting with a particular service. Therefore, overall, IoT is about providing a service than interacting with a device. It is very likely that most of you have felt the frustration when you try to access to a web page and it is either not loading at all, or either loading partially, or you may have come across situations you want to have a video or audio call, maybe to a different country, and then the call fails or you can't hear properly. So those kind of glitches are common in communicating over the internet. But when we are interacting with the device, our usual interactions, such as switching on a light bulb or switching on a TV, which is using a remote control, or the previous one you are using your own hand, where you're physically touching the device, you expect them to work immediately. So you don't expect anything unexpected happen. However, when we are interacting with devices over the internet, the same latency and unreliability communication issues come into play. And especially because our minds are trained always that physical objects are supposed to be responsive very quickly, and we have some expectation that when we are browsing internet it might get delayed. So we are kind of prepared, in the sense, even though we get frustrated, we are prepared to give a little bit more time. But when you are interacting with the device, you expect them to work, and if they don't, it could more frustrate end users than not loading a web page, which you kind of expect to happen some or the other. So if you are switch on the light, or if you are moving into a room and then you expect the light to go on, and then if it doesn't happen, or if it takes a little bit more time than you used to, it is very noticeable. and then it could lead to more frustration than we would usually do in a traditional internet browsing scenario. A key difference in IoT is that the communication between different components are asynchronous. One reason for this is that in IoT domain, the connected devices are running on batteries. Because of that, they require to conserve the energy by reducing any potential network communication over the internet or locally within a local area network. One way to achieve this is by not connecting all the time, but periodically connecting to other system components and then get up to date by talking to each other. So if you look at this particular example where you try to increase the temperature of your boiler, and then you might realize that it takes a little bit more time to actually increase the temperature. So the reason is that these small devices who manage this temperature, or the controllers, they are not connected to internet or the home hubs all the time. So they are periodically checking the temperature, what is the user preferred temperature, if user actually increases, and then that updated value pushed into the smart home system, and it will take a couple of minutes for a heating controller to go online and check for the new instruction, which is now the heater realized that temperature 21 Celsius. So now it needs to go and increase the temperature. So if the instruction was released using a mobile phone, it take a little bit more time to go to the home hub, and then it take another few minutes to push that value to the actual heating controller, and maybe even to update the screen which is on the wall, and then it take another couple of minutes to actually increase the temperature of the boiler. Another key difference in IoT is that the code you develop can be run on many different places. For example, if you consider a smart lighting system, some of the code might be on the microcontroller which is embedded within the light bulb itself. And then some part of the code could be within the hub where multiple lights are connected together. And then over the internet, over the local area network, it might be connected to the phone app. And then there's an app running on the phone. And then another piece of code might be on the web server, which communicate directly to the hub. So even in a simple case like this, there could be 4 different places the code could be run on. The system behavior could also be changed depending on where the particular piece of code would run. So in the previous example of a smart lighting system, if the internet goes down, could the system work? And the answer depending on where you run the code. So if you have a particular analytics or a rule set on the local gateway, then certainly if the internet disconnected, the rule will get triggered, and then the light bulbs will go on when you are, let's say, when you just move into the room, when the motion sensor detect your presence. However, if the rule is stored in your phone or on the internet, then if the internet connection get disconnected, it is likely that this rule will not be triggered. As a system designer, it is your responsibility to actually convey to the end users that where you going to store or process certain pieces of code, and then the implication of that. Ideally, you should give them the choice and also explain the trade-offs on where they want to run the code. But as a system designer, ideally, you should provide the capabilities or the broad range of capabilities that they can decide where they want to run the code. keeping the end users informed is really important, because if something goes wrong, the end users need to know what are their options and how they're going to recover the system. For example, one argument for storing all the rules in the local gateway could be that traditionally we think about computing devices as a one single device, or at least a one location for your mobile, for your tablet, for your computer. So you think them as a one unit, even though you might have like additional peripheral devices like printers. But in IoT, by nature, they are very distributed. So if you look at a security system, there could be a lot of devices spread across the house. For example, it could be motion sensor or a video camera. So each type of the component could be replicated across a particular geographical area, like your house. And then, even though this system is considered as a one security system, now there are a lot of endpoints that could fail. It also increased the resilience. For example, if one camera fails, the rest of the camera should work. And then as a designer, you need to think about how much resilience can each system can offer, and then how you could allow the end users to increase the capabilities or add on, like how you allow them to add on more cameras or more motion sensors as necessary. So as a system designer, it becomes your design strategies become more complicated, because now you need to think about how you expand in the future rather than just replacing. For example, in a traditional tablet or a mobile or a PC domain, you pretty much replace your device. But in IoT, there are certain categories of devices that require expansion over time, or adding new things over time. And then how do you design is something that you need to consider when thinking about IoT application. There is an implicit expectation that IoT devices should be able to configurable over time, which means that as a designer or a developer, that when you are developing your initial IoT system, you might envision that user might be, or user should be, use it in a certain way. However, end users should be able to configure the IoT devices in the way that they want. This means that as a developer, it becomes very difficult for you to imagine how the users might be going to use your particular system in the future. Therefore, you need to be quite visionary and imagine all the problems that the end user might face in the future, and also how the system could react to it. For example, you could develop an internet connected door lock with a camera, where someone delivers a parcel you could potentially open and then keep eye on the person until they leave. So what is your system design approach to make sure that either it automatically locked, or you be able to manually lock it, or ask the person who opened the door to lock it and then verify it? And then if the connectivity between you and the door get lost, how do you get a notification that the door is already locked now? So these are the complicated design decisions that you might need to anticipate when you are developing your own application, or even your system or your product is participating as a part of the bigger system, or if you are developing the camera component and then the door lock is designed by someone else, then these challenges are become more and more complicated. As I explained earlier, most of the IoT systems are independently very simple. However, as soon as we integrating more and more services or more and more components, the systems become increasingly complicated, because the number of ways that they can be configured become exponentially increase. What we have seen over the past few years is that each of these systems could be a lighting system or security camera or heating system. Individually, they have limited number of components, seems to be easily manageable. However, when they are connecting to each other, there are a lot of unexpected complications arises, especially when these components are developed by different manufacturers and companies. One problem could be the lack of standards, but more than the standard issue, the problem is that each of these systems can be configured in multiple ways, and then when they combine multiple systems together, the configurability become increased significantly, which is beyond a normal human being can do or configure by themselves. Therefore, a very simple, straightforward IoT systems could get complicated very quickly when we are adding more components and systems together. This figure clearly shows how the smart systems, which are very simple independently, could become very complicated when we are combining them together. And they could increasingly become more time consuming for individual end users to configure and manage them by themselves. The reason behind the success we achieved within internet domain, from emails to videos to web browsing, is that we were able to develop common standards. So different manufacturers or software developers could use them, and then their pieces of software could work together with each other. However, this is not the case at the moment in IoT domain. Each of the device manufacturers or the software developers has their own standards. One problem that makes it difficult to standardize is that the nature of the resource constraints. To facilitate the resource constraint and the need for conserve energy, different companies trying different strategies to minimize the data communication or the amount of data they communicate, and so on and so forth. Because of this, so far, we haven't seen a well-accepted standard. However, it is worth noting that there are a number of standards are within the incubators where consortiums are currently working together to develop these standards and make them available for everyone to use. However, it is very likely that we will see at least few different standards which are specialized for different types of devices depending on the resource constraint nature and the expected behavior. For example, how critical a particular IoT system need to respond to the user versus how they need to be reliable across different devices. Currently, different manufacturers are trying to achieve the interoperability using either company-to-company agreements or through some kind of if-then where intermediary services looking at two different systems and then try to transfer the communication between one system to the other. However, such translations are not really scalable, and also such translations add a lot of unreliability and dependency on third-party services. Therefore, in the future, we will very likely to see some amount of standards coming in that will facilitate interoperability between different manufacturers and devices. IoT is all about data. The both promises that IoT aims to deliver, which is the optimization, efficiency, as well as the convenience, these systems need to observe the real world in order to understand what is inefficient. For example, if someone driving to the city and struggling to find a car park, in order for an IoT system to intervene and help the driver, first, the system needs to know what are the usual patterns where parking is going to be available in a particular day, in a particular time. It could be either real time or it could be predictive. In either case, you need to monitor and capture the data, so you can look at the past data and predict where the next parking slot might be appear. In that way, you can actually tell the driver to go to a particular parking location where there is a likelihood that he or she will be able to park quite easily. Another example would be a heating system, where they tend to learn what is your preferences and at what times you will be at home and which part of the home you will be spending most of your time in a particular day and a particular time. Depending on that, heating system could actually adjust the temperature autonomously. In this way, the system can actually save the electricity bill by optimally managing the heating on behalf of you. And such autonomous behavior could also help or increase the convenience of the end user.